Welcome to G Fun Facts Online, the show where we explore the incredible science and technology that's shaping our future. Today, we're talking about something that, until very recently, was pure science fiction. We've all seen it in the movies, a hero clad in a high-tech suit soaring through the sky, defying gravity with the roar of jet engines. I'm talking, of course, about Iron Man. For decades, that kind of personal flight has been the ultimate fantasy. But what if I told you that fantasy is becoming a reality right now? And what if I told you that it's not just humans who are taking to the skies in this way? We are standing at the dawn of a new era, witnessing engineering marvels that are giving rise to both real-life Iron Man suits and a new generation of autonomous, jet-powered humanoid robots. Together, they are set to completely redefine the future of mobility. So buckle up, because today we're exploring how the sky is no longer the limit, it's the new frontier. Let's start with the human element. The dream of personal, jet-powered flight is being realized by a British company called Gravity Industries, founded by a man who is equal parts inventor, daredevil, and modern-day pioneer, Richard Browning. Browning isn't just the founder, as the chief test pilot. He is the man inside the suit, and his creation is a true marvel of engineering that has captured the world's imagination. So how does it actually work? Forget a single clunky jetpack. The Gravity Industries suit is a symphony of controlled power. It features 5 miniature jet engines. Imagine that, 2 on each arm and a larger one mounted on the back. These aren't just for show. Combined, they generate over 1,000 horsepower. That is more power than many supercars. This immense power can propel the pilot to speeds of up to 85 miles per hour and altitudes of 12,000 feet. The engines run on fuel you might recognize, like kerosene, premium diesel, or even standard Jet A1 fuel. But here's the truly mind-blowing part: the control system. There's no joystick, no complicated dashboard. The control of this incredible machine is surprisingly intuitive because it relies entirely on the pilot's own body. The pilot is the flight system. By subtly changing the angle and vector of their arms, they can steer, accelerate, decelerate, and hover with remarkable precision. Think about that for a moment. To fly, you essentially point where you want to go. This means that piloting the suit is an incredibly physical task. It requires immense core strength and stability to manage the thrust and maintain balance. You are truly one with the machine. The design and construction of the suit are just as cutting edge. To keep it as lightweight as possible without sacrificing strength, the engineers at Gravity Industries make extensive use of 3D printing. Components are crafted from advanced materials like aluminum, high-strength nylon, and even steel. This is a testament to how modern manufacturing is enabling a future we could only dream of before. Now, you might be thinking this is an amazing, thrilling experience for the super rich, a new kind of extreme sport. And you'd be right, in part. But the applications for this technology go far beyond the sheer thrill of personal flight. They are proving to have immense potential in critical, life-saving sectors. One of the most exciting developments is a partnership between Gravity Industries and the Great North Air Ambulance Service, or GNAA. They have been testing the suit's ability to deploy paramedics to remote and difficult-to-reach locations. Imagine a hiker who has fallen in a mountainous region, a place where a helicopter can't land and a ground team would take hours to reach. With the jet suit, a paramedic could be airborne and on the scene in minutes, not hours. This drastic reduction in response time could literally be the difference between life and death. The suit's agility allows a pilot to navigate treacherous terrain, landing on a small patch of uneven ground that would be impossible for any other vehicle. The military is also taking a very serious look at this technology. The Royal Marines, for example, have tested the suit for what they call maritime boarding operations. Picture a situation where a team needs to board a vessel at sea, quickly and discreetly. Instead of a slow and vulnerable approach by boat or helicopter, a single soldier in a jet suit could fly from a distance, land on the deck of the target ship, and secure it for the rest of the team to follow. It's a tactical advantage straight out of a video game. And yes, of course, there's the entertainment factor. The world has already seen the first ever jet suit race, held in Dubai. This hints at a future of high-speed, three-dimensional sports, a real-life Quidditch or pod race that could become a global spectacle. While we humans are mastering the art of personal flight, a parallel and equally groundbreaking field is rapidly emerging: jet-powered humanoid robots. This is where science fiction truly begins to blur with reality. If the jet suit is Iron Man, then this next step is something like the Terminator meets the Rocketeer. A major breakthrough has come from the Italian Institute of Technology, or IIT. They have created Iron Cub 3, the world's very first jet-powered flying humanoid robot. This remarkable creation represents the convergence of two incredibly complex fields: advanced robotics and aeronautics. The Iron Cub 3 is an evolution of a pre-existing robot platform called iCub, but the team at IIT had to heavily modify it to withstand the extreme forces of flight. It's equipped with 4 jet engines, 2 on its arms and 2 on a backpack, which can generate a combined thrust of over 1,000 newtons. That's more than enough force to lift the robot off the ground and keep it airborne. But strapping jet engines to a robot is the easy part. The real challenge is surviving the flight. The forces are immense, and the engines generate terrifying temperatures, reaching up to 800 degrees Celsius. To handle this, the robot was given a new titanium spine and covered in specialized heat-resistant materials. The engineering is one thing, but the intelligence is another. How do you teach a robot to fly? It's not like it can learn from instinct like a bird. This is where the challenge becomes less about hardware and more about sophisticated software. Researchers at IIT, working with experts from Stanford University and Milan Polytechnic, had to develop a new brain for the robot. They used deep learning algorithms and conducted countless hours of wind tunnel tests. These tests allowed them to create a precise aerodynamic model of the robot, which they then used to build a robust flight control system. The AI has to manage the complex, ever-changing aerodynamics in real time to keep the robot stable. And their work has paid off. The Iron Cub 3 has successfully taken off, hovered at a stable altitude, and landed safely. It's a monumental first step towards a future of autonomous flying machines that can perform tasks in the air. And Italy isn't the only place where this innovation is happening. In China, researchers at Guangdong University of Technology have been developing their own flying humanoid robot called the Jet HR-2. It's designed specifically for search and rescue missions. Their approach is a bit different, using ducted fan thrusters on the robot's waist and feet. This shows that there isn't just one path to achieving aerial mobility in a humanoid form factor. Brilliant minds around the world are tackling the problem from different angles. So what does this all mean for the future? What kind of world are we building with this technology? The development of both human-piloted jet suits and autonomous jet-powered humanoids signals a profound shift in our very understanding of mobility. In the near future, the jet suits piloted by humans will likely continue to find their place in specialized fields. We've talked about emergency services and military operations, where their unique combination of speed and agility in complex environments is simply unmatched. But looking further ahead, the true revolution might lie with their autonomous robotic counterparts. Humanoid robots are already being integrated into manufacturing and logistics because they are designed to work in environments built for humans. They can use our tools and navigate our spaces. Now, add the dimension of flight to that equation. The possibilities become almost limitless. Imagine a major earthquake or a hurricane. A disaster zone is a chaotic and dangerous place. A team of these jet-powered humanoid robots could be deployed. They could navigate through the rubble on foot, just like a human rescuer. But when they reach an impassable obstacle, they could simply take to the air, flying over it to survey the area from above. or to reach survivors trapped in the upper floors of a collapsed building. They could deliver medical supplies, establish communication links, and perform tasks that are currently far too dangerous for any human. Think about infrastructure. These flying robots could be used for the inspection and maintenance of massive structures like bridges, power lines, and wind turbines. A job that would normally require a team of specialists, cranes, and scaffolding could be done in a fraction of the time by a single autonomous robot, and with zero risk to human life. We could even see them used for exploration in extreme environments here on Earth, or perhaps one day on other planets, becoming our eyes and feet on Mars. Of course, the idea of everyone having a personal jetpack for their daily commute is probably still a long way off. There are major challenges to overcome, like fuel efficiency, noise pollution, and, most importantly, safety regulations. But the groundwork for this new era of mobility is undeniably being laid today. The incredible advancements we're seeing in engine technology, artificial intelligence, and materials, science will continue to push the boundaries of what is possible, likely faster than any of us expect. From the real-life Iron Man, Richard Browning, pushing the absolute limits of human flight, to the silent, autonomous ascent of a robotic counterpart like Iron Cub 3, the journey into the third dimension of personal and operational mobility has officially begun. The age of science fiction is now science fact. Thanks for tuning in to G Fun Facts Online. Join us next time as we explore another amazing piece of our future.